Hi, everyone. Welcome to Organic Science. Curated by the Organic Guy and aided by AI, Organic Science shares hidden, hard-to-digest organic and sustainable farming research as bite-sized, brain-friendly insights you can use daily.
So today we're doing a deep dive into a really important study. It's from the Rodale Institute, their Farming Systems Trial, or FST. And this isn't just like a quick look. It's 30 years of research comparing organic and conventional farming side by side. Our mission, pull out the key stuff, the most important insights, to give you a shortcut to understanding this whole organic versus conventional debate.
Yeah, absolutely. And just so we're all on the same page, when we talk about sustainable farming in this context, based on Rodale's work, we mean a system that can basically keep the soil fertile
Mm,
or even improve it forever, indefinitely.
yeah.
And organic, for this study, it's pretty straightforward.
Mhm.
Farming without synthetic chemicals, trying to work with nature, mimicking natural processes. What makes the FST so valuable is this long-term comparison. Seeing them operate right next to each other for decades, well, that gives us some crucial real-world data on what those terms actually mean in practice.
Okay, so let's set the scene. The FST itself. When did this whole thing kick off and what were they trying to figure out at the start?
Right, so it started way back in 1981.
Yeah.
That makes it the longest-running direct comparison of organic and chemical agriculture in America. And its original goal was actually quite practical. They wanted to study the transition. What actually happens on a farm when you switch from using lots of chemicals to going organic.
Right, that transition period. So what did happen? Was it smooth sailing for the organic plots right away?
Well, that's one of the really interesting parts. In those first few years, yeah, there was a dip. The yields in the newly organic systems did decline initially, but, and this is key, after that adjustment phase, they bounced back. The organic systems caught up, and over the long haul, they consistently matched or even sometimes beat the conventional systems yields.
Okay, so it wasn't an instant switch, but they got there.
Exactly. And the trial looked at three main ways of farming to compare. First, there was the organic manure system. Think of it like a mixed farm, maybe with dairy or beef cattle. They had a really long crop rotation, lots of different crops cycled over, like 7 crops in 8 years. It included feed grains, but also perennial things like hay. Fertility came from cover crops, plants grown specifically to enrich the soil plus manure or compost. And that diversity, that long rotation, was also how they managed pests. Then there was the organic legume system. This was more like a cash grain farm, selling crops directly. Shorter rotation here, but still focused on annual grains and cover crops. The big difference. Fertility came only from those leguminous cover crops, plants like clover or vetch that fix nitrogen from the air. Again, rotation was the key for pest control. And finally, the conventional synthetic system. This mirrored, well, how most grain is grown in the U.S. Heavy reliance on synthetic nitrogen fertilizer for growth and chemical herbicides for weeds. They even added genetically modified herbicide-tolerant corn and soy later on in 2008, just to keep it current with typical practices.
Wow, okay, so quite different approaches. And that rotation difference sounds pretty significant, 7 crops versus just 2.
Huge difference. The diversity in the organic systems is fundamental to how they work, breaking pest cycles, building soil fertility naturally. The conventional system is much more simplified. Just corn, then soybeans, then back to corn.
And they focus mainly on corn and soybean for the comparison, right? Which is
Yeah.
important because, well, those 2 crops cover a massive amount of U.S. farmland.
Exactly. Back in 2007, it was almost 49% of all U.S. cropland. So yeah, what happens with corn and soy in this trial is incredibly relevant for American agriculture as a whole.
Okay, so let's talk about the foundation, literally. The soil. The study calls healthy soil the foundation for present and future growth. What did 30 years show about how these systems treat the soil?
This is where the difference becomes really stark. The FST concluded that organic farming is, and I quote, far superior to conventional methods when you're talking about building, maintaining, and actually replenishing the health of the soil.
Yeah.
Just based on soil health alone, the study is pretty unequivocal. Organic agriculture is more sustainable. Full stop.
Far superior. Yeah. Okay. What specific things did they measure? How did the soil actually change?
Well, several key things. The organic systems actively improved soil health over the 30 years. The conventional systems, they basically stayed the same, or in some ways, maybe even degraded slightly. Soil carbon, for instance, hugely important for structure, water retention, and, climate change. Carbon levels went up the most in the organic manure system than the organic legume system. But the conventional system, in the later years of the study, it actually showed a loss of soil carbon.
Wow, losing carbon. That's
Yeah.
not good.
Not good at all. It means the organic systems were actively pulling carbon from the atmosphere and storing it in the ground. The conventional wasn't. And then there's water. Organic fields were much better at absorbing rainwater. They measured water percolating down into the soil. It was 15 to 20% higher in the organic systems.
So less runoff.
Exactly. Less runoff, which means less soil erosion, and more water recharging the groundwater underneath. That's vital, especially in dry areas or, during droughts.
So the organic soil acts more like a sponge.
Precisely. It holds on to water better, creating this sort of in-storage supply for plants when rainfall is scarce. Conventional soils, partly because of the synthetic nutrients, which are very soluble, tend to let water and those nutrients leach through faster.
Meaning the nutrients end up in rivers and lakes instead of feeding the crops?
Right. Lost from the farm system, potentially causing pollution downstream. And you can even see the difference. Organically managed soil typically looks darker, richer. You can see the aggregates, the little clumps more clearly.
Then those clumps are important.
Very. They create spaces for air and water, help roots penetrate. It's a sign of healthy soil structure.
And you mentioned erosion. There was a pretty shocking statistic about the Corn Belt.
Yeah, it's sobering. Separate research shows America's Corn Belt is losing topsoil way faster than official estimates, maybe up to 12 times faster. But in the FST, the organic systems were actually building topsoil over time, regenerating it.
Building soil versus losing it. That's
Yeah.
fundamental. Okay, but this brings us back to that big question. Soil health is great, but can organic farming actually produce enough food? What about the yields?
That's always the million-dollar question, isn't it? And the FST provides some really compelling answers over its 30 years. For corn and soybeans, in the systems that use tillage, the yields were basically the same. Equivalent. Organic matched conventional. Same for wheat, actually. Equivalent yield. Okay, that itself is pretty significant.
It is. But here's the really big aha moment. Drought years. When conditions got dry, organic corn yields were 31% higher than conventional corn.
31%. Wow. Yeah. Like in one moderate drought year, they got 134 bushels per acre from organic versus only 102 from conventional. That's a huge difference when things get tough.
And how did that compare to, say, those genetically engineered, drought-tolerant varieties they added to the conventional system?
That's another fascinating point. Those GE drought-tolerant varieties, they only boosted yields by about 7% to 13% in drought conditions. The organic system, just through building healthy soil, outperformed them significantly.
So the low-tech, soil-focused approach was more resilient than the high-tech genetic solution.
In this trial, absolutely. It highlights the power of that healthy soil sponge we talked about holding water for when the plants need it most. And another thing on yields, weeds. The organic crops could handle a lot more weed competition and still produce the same yield as the conventional crops, which were kept almost weed-free with herbicides.
So they were more tolerant of weeds. Why is that significant?
Well, think about the rise of herbicide-resistant superweeds in conventional farming. It's a huge problem, forcing farmers onto more toxic chemical cocktails. The FST suggests organic systems might be inherently more robust, less dependent on perfect weed control.
Okay, so yield parity overall, but much better performance under stress and maybe less susceptible to weed issues. But stepping back, what about the bigger feeding the world argument?
Right, because it's not just about yield per acre in one field. The study, and others it references, argue that feeding the world is more complex. You look at major reports like from the UN's Food and Agriculture Organization, the SAO. They stated that organic agriculture does have the potential to secure global food supplies, but with less environmental damage. Another UN report went even further, suggesting that agroecological methods, which heavily overlap with organic, could potentially double global food production within 10 years, especially by supporting small farmers.
Double.
By focusing on improving systems in developing countries where yields are currently low, using methods that build soil, conserve water, and don't rely on expensive inputs, studies have shown that when struggling communities switch to organic, they can see harvest increases of like 180%.
Wow.
So the argument emerging from this type of research is that small-scale, resilient, organic-style farming is actually the best bet for feeding the world sustainably and equitably now and in the future. It's not just about sheer bulk from industrial farms.
That really shifts the perspective. Okay, let's talk money. The farmer's bottom line. Is organic farming actually profitable, or is it more of a struggle despite the environmental benefits?
That's another area where the FST and related data provide some perhaps surprising insights for some people. The short answer, organic farms are often more profitable, significantly so. The Organic Trade Association, for example, cites figures showing organic farmers netting around $45,000 a year compared to about $25,000 for conventional farmers.
Almost double the profit.
Yeah, it's a substantial difference. And the FST's own economic analysis, looking at data from 2008 to 2010, backs this up strongly. Their organic systems were nearly 3 times more profitable per acre than the conventional system. We're talking an average net return of about $558 per acre per year for organic versus $190 for conventional.
3 times. How? Are they just getting paid way more for organic crops?
Well, the organic price premium definitely helps, that's true. But what's really striking is the FST found that even without any price premium, the organic systems were still competitive.
Really? Why?
Lower input costs. They weren't spending heaps of money on synthetic fertilizers and pesticides. Their costs were marginally lower, enough to keep them competitive even at conventional prices.
So lower costs make up for potentially slightly lower yields in some cases, or just boost profits when yields are equal.
Exactly. And when you factor in the price premium, the profitability really takes off. Interestingly, the most profitable crop in their trial was organic wheat, netting over $800 an acre per year.
And the least profitable?
That was the conventional no-till corn, making only about $27 an acre per year in that period.
$27 versus over $500 for the organic systems average? That's stark.
It really is. It challenges the assumption that conventional is automatically the most economically efficient. The FST suggests organic is a very sound financial choice for farmers.
And what about the impact beyond the individual farm on rural communities?
That's another positive angle for organic. Research shows organic farms tend to create more jobs, over 30% more jobs per hectare, actually. More of the money spent on an organic farm goes to paying people, rather than buying chemical inputs or massive machinery. So it could potentially help revitalize rural economies, reversing that trend where conventional ag replaces labor with chemicals.
More jobs, better profits for farmers. Sounds like a win-win. Okay, let's connect this to the environment again, but specifically energy and climate change. What's the footprint like?
Yeah, the energy side is critical.
Yeah.
Conventional agriculture is incredibly energy intensive. Think about manufacturing synthetic nitrogen fertilizer. That alone takes huge amounts of natural gas, basically fossil fuels. Then you have to transport those fertilizers, pesticides, run the machinery to apply them. It all adds up. Agriculture overall contributes about 12% of global greenhouse gas emissions.
So how did the systems in the FST compare on energy use?
Big difference again. The organic systems used 45% less energy overall compared to the conventional system. 45%.
Wow. Where was the biggest energy use in each system?
In the organic systems, the main energy input was diesel fuel for tractors, field work, etc. Pretty straightforward. But in the conventional system, the single biggest energy hog was producing that nitrogen fertilizer. It accounted for 41% of the total energy used in that system.
Just the fertilizer production.
Just the fertilizer. So overall, the organic systems were much more energy efficient, about 28% higher production efficiency, meaning they produced more crop per unit of energy consumed.
In greenhouse gas emissions specifically.
Following from the energy use, the conventional systems emitted almost 40% more greenhouse gases per pound of crop produced compared to the organic systems. Again, for conventional, the big sources were fertilizer production and fuel use. For organic, it was mainly fuel use and, to a lesser extent, energy use to produce the seeds.
So a significantly lighter touch on the climate from the organic side.
Definitely. Less reliance on fossil fuels, and remember, they were also building carbon in the soil, which helps pull CO2 out of the atmosphere.
Right, double benefit there. This all leads to maybe the most important connection for many people, our own health. What does this trial and the practices it compares mean for human health?
This is crucial. The FST itself looked specifically at water quality, which has direct health implications. Remember how organic systems were better at holding water and preventing runoff? Well, the water leaching out of the conventional system plots more often exceeded the legal safety limit for nitrates in drinking water. That limit is 10 parts per million.
Nitrates in drinking water, that's linked to health issues, right? Especially for infants.
Yes, particularly blue baby syndrome. So higher risk from the conventional system's runoff. And then there's atrazine, a common herbicide used in the conventional plots. The levels leaching out sometimes exceeded the EPA's maximum contaminant level for drinking water. And perhaps more worryingly, all the water samples from the conventional plots had atrazine levels above 0.1 parts per billion.
And why is that specific level a concern?
Because that's a concentration that's been shown in other studies to cause deformities in frogs. It raises serious questions about its impact on ecosystems and potentially human health, even at low levels.
Okay, so the FST showed less potentially harmful stuff getting into the water from organic fields.
Correct, which is vital when you zoom out and look at the broader research on the chemicals used in conventional farming. These pesticides, herbicides, insecticides, fungicides, they're literally designed to kill things. And a growing body of evidence suggests even low-level exposure could be causing serious health problems for us.
Like what kind of problems?
Well, studies outside the FST have linked atrazine exposure around the time of conception to lower math and reading skills in kids later on. Other research measured organophosphate pesticides, common insecticides in children's urine. When those kids were switched to an organic diet, those pesticide traces disappeared.
Wow, a direct dietary link.
Yes. And think about glyphosate, the active ingredient in Roundup, used on those GE crops in the FST's conventional system. While it's legal at low levels in food, lab studies on rats have linked it to DNA damage, infertility, low sperm count, even certain cancers.
That's concerning.
It is. And pesticides, even some that were banned years ago, are still showing up in human breast milk and umbilical cord blood. It shows how persistent and pervasive these chemicals can be.
And what about the other ingredients in pesticide products? The inactive ones?
That's another huge issue. Often, those so-called inactive ingredients can be just as toxic, or even more toxic than the main active chemical. But get this, they generally aren't required to undergo the same level of health testing before being approved.
Seriously? So we don't even know the full impact?
Largely no. Some research even suggests certain agricultural chemicals might alter our DNA epigenetically, meaning the effects could potentially echo down through generations. You have over 17,000 different pesticide products approved for use, exposure linked to various cancers, brain, and nervous system issues. Yet the EPA has only required safety testing for a tiny fraction, less than 1%, of all the chemicals in commerce.
It feels like we're running a massive experiment.
That's how some scientists describe it. So when the FST shows organic systems drastically reduce the leaching of these types of chemicals into our water, that's a direct, measurable benefit for public health, reducing our exposure at the source.
Okay, so we've covered a lot of ground today. 30 years of the Farming Systems Trial, digging into soil, yields, economics, energy, and health. It's quite a picture.
It really is. And if you step back and look at that big picture, the FST strongly suggests that our current dominant chemical-based way of farming has some serious weaknesses. Depleted soil, contaminated water, negative health impacts, struggling rural communities. It's not looking sustainable in the long run. Organic practices, as demonstrated in the trial, offer a path towards genuine sustainability by actively building soil, working with natural nutrient cycles, promoting biodiversity, and minimizing all those synthetic inputs.
And Rodale Institute seems pretty convinced. Their conclusion is that organic methods improve food quality, soil, water in our rural areas, more jobs, better income for farmers, more trust in the whole system.
Yeah, they're very confident in the findings. And what's really great is that the FST isn't just a one-off anymore. Its findings are being confirmed by similar long-term trials starting up around the world. Rodale is continuing the trial, looking into new questions, but the fundamental comparison has really shifted the conversation.
So to wrap up, we want to leave you, our listener, with a final thought from Rodale based on this incredible 30-year deep dive.
They put it this way: we have shown that organic can feed the world. Now it is time to take on the matter of feeding the world well.
Feeding the world well. That definitely gives us something to think about, doesn't it? What that means for our food, our health, our planet. We really encourage you to keep exploring these topics.